there's not as much to look at today, but there are two types of equations that we actually never did explore last year. One could be illustrated by the following. If I say 2 times 3x plus 5, that quantity, plus 9, equals 6 times y, times x. I prefer x, as one student pointed out today. Y's can look like 4's. X plus 3, that quantity, plus 1. If I go through all of the steps that I have been doing, the distributive property, distributing 2 over 3x gives me 6x. 2 over 5 gives me 10. Bring down the 9. That equals 6x plus 18 plus 1. Combining like terms gives me 6x plus 19 on this side of the equation, and 6x plus 19 on the other side of the equation. It's looking odd. Well, just to continue, if I get rid of all the variables, I will come down to 19 equals 19, which is a true statement. It is always true. 19 always equals 18. Or, if I wanted to keep in the same vein as we have in the past, bringing the variables to one side and the numbers, supposedly, to the others, if I go all the way down as far as I can, I get the true statement that 0 equals 0. Both sides of the equal sign have identical terms. It is called an identity. When all of the variables cancel out, identity. The variables cancel out, and I'm left with a true statement, a true numerical statement. It's called an identity. And what does that mean? Well, let's just decide. Let's plug a number in for x. Pick any number. Let's make it easy. If I say 6 times 3, for example, if I say 6 times 3 plus 19, well, that equals 6 times 3 plus 19. On the other hand, if I chose the number 6 times, 6 times 5, 6 times 5, no matter what number I plug in for x there, you will see that it is always true. In other words, identity, all real numbers are solutions. Meaning anything I plug in will make it true. That's an identity. Think of identical twins. Okay, on the other hand, if I solve an equation that looks like 3 times x plus 2 is equal to, 3 times x plus 2 minus x is equal to 2 times x plus 1. I can do all my algebraic procedures. 3x plus 6 minus x equals 2x plus 2. Lo and behold, this says twice a number plus 6 is equal to twice the number plus 2. Well, right away, you can sense that something's wrong. But let's keep going. Minus 2x, minus 2x, minus 2, minus 2. And if I carry it all the way out, I get 4 is equal to 0. Not. If all of the variables cancel out and you get an untrue statement, an untrue numerical, meaning there are no variables involved, what that means is that there is no solution. There is no number I can plug in that would make, this true. Three times 4, for example, would plus 12. Anyway, here, if I plug it in on this line, 2 times 4 is 8, plus 6 is 14. Can never be the same thing as 2 times 4 or 8 plus 2. It's impossible. That's what equations with no solutions look like. There's one other thing that comes up in terms of assigning variables in word problems. In one of the problems that you need to do tonight, or maybe not one that you have to do tonight. But the bottom line, this comes up frequently, and it will be coming up later this week, and that is that if all you are told in a word problem is that the sum of two numbers is, or the total hours worked, or anything like that. If I'm talking about two different things. For example, in the sum of two numbers, obviously I have two numbers worked. The sum of total hours worked at, I should add, at 2 jobs. You always have to start out, you need a way to assign the variables. So, if I say 1, let's say the sum of two numbers is 7. I can call one x, the other would be 7 minus x, the total minus the number. So good luck on all that. My phone is ringing.